Hi, so in this video I'm going to talk to you about scientific notation and another way of writing really big numbers. So before I get into it, I want to show you all these different numbers that you may or may not be aware of. This is the number of stars in the Milky Way galaxy. This is the population of the world. This is the distance to the sun. This is how long ago it was since dinosaurs were around. This is how much Ronaldo earned in a week at some point. And then this is the diameter of a grain of sand. This is the length of a red blood cell. And this is how wide an atom is. What all of these numbers have in common? The thing they all have in common is they're very difficult to say, right? For example, look at this one about the atom, 0.00000000001. Or if you're trying to think of the place value, most people get lost after you get to the hundredths, tenths, thousands. What on earth is that? So there must be another way to write this. So scientists and mathematicians realised that working with really big numbers and then really tiny numbers could get a bit messy. It was difficult to say, it took time to write. So to solve this problem, they developed a shorthand that enabled them to write very big or very small numbers without so many place values or without so many zeros, and that is called scientific notation. Now it's sometimes called standard form as well, so if you ever see a question asking you to write something in standard form, that's the exact same as scientific notation. So these are all the numbers that I just showed you on the pictures a second ago. I want you to look closely at them again and see if you can figure out what the connection is. Now you should notice that the numbers at the start of each number are pretty similar. There's your 1, there's your 1. There's your 7, there's your 7. There's your 1496, but there's your 1496 in a slightly different way. Then, these numbers, the powers must have something to do with it as well. So if you look at the first one, it's got a power of 11. How many zeros are there in my number? Well, there's 3, 6, 9, 11. There's 11 zeros. And then there's a power 11. The next one, you'll notice there are 9 zeros, 3, 6, 9 zeros, 9 for your power. So in the next number, it's got a power 8, so you'd expect that to have 8 zeros, wouldn't you? Hold on, 3, it's only got 5 zeros, but it does have 3, 6, 8 numbers after the 1. So at first glance, you might think that the power is a number of zeros. But then when I start bringing in other numbers, you'll notice it's not that. The power is actually how many places there are after your first digit. Mathematically, though, it means something else. So I'm going to take this example here with the times 10 to the power 8 on it. So if I give you 1.496 times 10 to the power 8. Now, times 10 to the power 8 really means you're doing times 10, times 10, times 10, times 10, 8 times over, right? And because that's a short way of writing it. If you times something by itself 8 times, you write it as a power 8. And we know that times by 10 is quite often adding zeros. But in terms of this, it's moving the decimal point number of places. So we can move it 1, 2, 3 places, and that deals with those ones. But then I've got another 5 to go. So if I add on 5 zeros now, 1, 2, 3, 4, 5, that gives me the number I started with. I started with 1496, 1, 2, 3, 4, 5. So the power is telling us how far we have to move our decimal point, technically. Okay, it's the amount of times we are multiplying by 10. So let's write this down in a general form. So to write any large numbers in scientific notation, we have to remember this here. This bit in green is what we are after for our answer. We need a number times 10 to a power. Now the number at the front has to be between 1 and 10. So I'm going to show you 3 examples and see which you think is acceptable. Can I have 93 times 10 to the power 2? Can I have 0.93 times 10 to the power 3? And can I have 9.3 times 10 to the power 5? Which of those would be an acceptable answer? Well, not the first one because 93 is not between 1 and 10. And not the second one because that's smaller than number 1. 9.3 would work. So this number here should be only have one number really in front of the decimal point. And then the power tells you how many places you are moving that decimal point, how many places you are either timesing or dividing by 10 by. So let's look at some examples. So I want to write each of these numbers into scientific notation. Now, what I tend to talk about is the decimal point always goes after that first digit. So they put the decimal point after the 3. So that becomes 3.47. We can drop any zeros at the end because in decimals we don't need zeros after your digits because they end up having significant figures. And our aim is like, well, we're trying to write this shorter. So if I keep adding those zeros, I've not written it any shorter at all. So it's 3.47 times 10. And then let's decide our power. So our power is going to be how many places we've moved the decimal point from the end into there. And you have moved it 1, 2, 3, 4 places. So it's a power of 4. And you might just also notice how many digits are after the 3. There are 4 digits after the 3. So our answer for the first one is 3.47 times 10 to the power of 4. My second one, we're going to put the decimal point after the first number. So it's going to be 7.2 times 10. How many places have we moved the decimal point from the end into there? We have moved it 3 places, so it's 7.2 times 10 to the power 3. It is not the number of zeros, all right? Okay, my next one, the decimal point will go after the first digit, so that makes it 6.9. So 6.9 times 10. How many places am I moving the decimal point? Remember, it's hidden at the end. From the end into there, I'm moving it 2 places. So the power 2. And the last one on this slide, decimal point goes after the first digit, so it's just 8. You don't have to write 8.0. It's just going to be 8 times 10. And then I've moved that imaginary decimal point in 1 place. And when I look at that sum, that is 80 is 8 times 10. You just don't always write the power 1 on it. Okay. Let's do some bigger numbers. So decimal point after the first number. So this will be 9. Point. Keep all those other numbers. 462 times 10. And then think how many places you're moving it from the end into there. You've got 5 digits there. So that would be power 5. Although it doesn't look much like a 5. Second one, decimal point after the first number. So it's 5.0, but we don't need it. So it's just 5 times 10. And we've got 3, 6, 8 places. So when it's big numbers, I sometimes put zeros in to make it easier to count. So from the end of the number into there are 8. Now notice, yes, there are 8 zeros there, but it's 8 places after where the decimal point's going. 6 million, I would always encourage you to try and write that number out first. 6 million is 6 with 6 zeros. So that would be 6 times 10 to the power from the end is 3, 6 places. So 6 times 10 to the 6. Any singular million is always going to have a power 6 on it because to be in the millions, you have 6 digits. It's a 6-figure number. Right, 11.5 million. So that is really 11,500,000. Now that would be not 11.5. You put a decimal point after the first number. So it's 1.15 times 10. But how many places are we moving it from the end? So we're moving it 3, 6, 7 places. So that's 1.15 times 10 to the power 7. Number 9, decimal point after the first number. So that would be 6.324. How many places am I moving that decimal point? Now watch, the decimal point's in the number this time. It's not at the end. I am moving it from after the 2 to after the 3. So I'm after the 2 till after the 6. So I'm actually only moving it 2 places. And that's a wee tricky one. And then my last example is sometimes you've got really hideous numbers like that and you have to write that into scientific notation. You have to do some element of rounding, otherwise it's not shortening down the number at all. So to 1 decimal place, the decimal point goes after the first number, so it's 3 point. We're looking at this. Is that going to stay a 2 or is it going to become a 3? Well, the next number is a 7, so that will turn it to a 3. So it's going to be 3.3 times 10, and I'm looking for how far I'm moving it from here to here. Now that has got 1, 2, 3, 4, 5, 6, 7 digits. So I'm moving that 7 places. Okay, so that one would be 3.3 to 1 decimal place. I'm just going to write that at the side that I did it to 1 decimal place. Because you will be asked to do that now and again. So that brings you to the end of the video. Here's some you can try for yourself if you want to. And if you want to pause and then unpause, the answers will appear up for you. And there's the answers there. Thank you very much for watching.